This is TWiT.
Yeah, here's an arena right here. So you can see, it's not a very big size speaker. And what's really neat about these is this is actually a stereo loudspeaker. So a lot of the other speakers in this category, in this multi-room wireless space, the speakers of this size that they're offering is mono. And I think that's kind of crazy that you're having 21st century wireless connectivity producing a 1950s mono sound. Whereas,
good point.
Yeah, exactly. And the problem is, the general public, when they're going to the store, they don't understand that. They're just saying, oh, this is a wireless speaker, and it sounds pretty good, but you don't get any of the stereo listening experience because they're mono. And so then you have to go buy two speakers, but then obviously that's twice as much cost and also twice as much real estate. And there's many places where you want to put a speaker where you just have barely enough room for one. For example, like a kitchen countertop, which is very special space for appliances and cutting boards and everything like that. The last thing you want to do is having a bunch of speakers everywhere. So with one of our speakers, you can actually have a nice big stereo listening experience through the advent of our Trillium technology of upmixing the 2-channel stereo into the 3 channels and having coming out the three sides.
That's what I want to. That's what I'd love for you to talk about next. Is this Trillium technology, which was first introduced in your Bluetooth speakers, and now you're using it here as well. How can you possibly get a good stereo image, good stereo separation from a single box like that?
Well, we're doing it a little different than some of the other speakers that are, claiming stereo, where they have a left driver and a right driver a few inches apart. With what we're doing, the Trillium is actually looking at, what's kind of common and what's different between the left and the right channels, and is then and it's doing that selectively based on the frequency band. And it's then, sending and directing it to the respective left and right channels, such that these sound waves from the 3 channels actually blend in air and mix and create kind of a virtual left-right speaker outside the box. And so,
so what we're looking at here, those of you who are looking at the video can see kind of a diagram of what's going on here. That small little black rectangle in the center, sitting on the coffee table, is the speaker itself. And what you're claiming is that the quote-unquote virtual speakers are actually out beyond the physical confines of the cabinet itself, right?
Exactly. And it works, together with your room, and such that the end result, when you are listening to it, you actually get this perception of having, left, center, right imaging. You have, a nice sound stage with width and depth that reminds you of a traditional stereo system. It's not, of course, exactly the same as a left-right pair of speakers, but it gives you a very similar type of experience, like you are getting a nice big spacious sound in the room. And what's cool about it is because the speakers are the left and the right are virtual, you don't have the same comb filtering like you do with a traditional pair of speakers. So with a traditional pair of left and right speakers, you usually sit in the center and you get a nice phantom center image of the vocalist singing. But the minute you move your head to the right, well, now that image doesn't stay where it was. It's now actually starting getting closer to the the right speaker, or you move your head to the left and it's to the left speaker.
Isn't that going to happen here too, though?
No, because we have the center is coming predominantly out the center channel driver, and so when you are exactly, and so when you're sitting and listening, you can be sitting either in the front, head on, or off to the left or off to the right, and the center image will always still be in the center, and then you'll have a nice big sound field around it. And so what this gets us is a much wider listening area for the whole family to enjoy it.
Tell us a little bit more about Trillium and how it works. You were starting to say something about how you identify what's common to the right and left channels, and I guess what's not common in terms of frequencies or parts of the signal.
Exactly. So we're looking at what's common and what's different between the channels. And the ear is and the brain is you pick up spatial cues primarily in the mid-range and treble. And so that's where we're looking at what's going on and correlated and uncorrelated between the channels, and then feeding that to the 3 channels. And then we actually have in the low frequencies, all 3 channels are working in unison, and that's how we're able to get the good deep bass out of the speaker of that size.
So if you've got 2 signals or 2 elements that are identical in the right and left, do those get then rerouted to the center, or are they also coming out the right and left?
They would be predominantly routed to the center, but the low frequencies would also come to the left and the right.
I gotcha. Okay. And then what's different about the right and the left would come out of the right or left, depending on where it is.
Exactly. And so, if you look at, what's called like, left minus right, right minus left, that's what is kind of getting redirected to the different channels. And again, it's going on predominantly in the mid-range and the treble, where you hear the spatial cues. And then at the low frequencies, where the bass is often kind of mixed in mono to begin with, we unify it and have it come out all 3 channels, such that they can work together with the radiators in the arena and get the a very powerful bass response and big dynamic range out of the speaker.
That must take some pretty serious DSP power to do what you're talking about.
It's taken a lot of time because when we first started on the Trillium concept with the Bluetooth speakers, the goal was to produce a speaker with a big sound from the small singular size. And so we thought about it, and I said, well, I think I have some ideas how to do that from some previous experience I have as a hobbyist. And so we started prototyping it originally on a breadboard with op amps and resistors and capacitors and making a simple circuit.
I remember doing that, yeah.
Exactly. And so we proved it out that way, and then from there migrated it over to DSP. And so it's not just doing the processing, you also have to do the equalization such that all the channels are reproducing the frequency range appropriately. And so it's kind of a challenging system to tune, because you don't really have a traditional left channel measurement and right channel measurement. You're doing some anechoic style measurements, as well as a lot of in-room measurements and listening, and trying all different types of music, different listening environments, and just keep adjusting the DSP settings such that it always sounds correct and natural. We have some nice hi-fi speakers here, like some BBC LS35s that we use for reference, and have some old Celestions and others that we use to kind of make sure that we're trying to provide a very good top audiophile type of experience with the speakers.